morning, everyone. Today we'll be having a look at the second part of how the internet works. Basically, the first part, just to recap, we looked at more of the physical infrastructure and then looked at some of the protocols. If you guys can remember, we touched on TCP IP, we touched on DNS records, which is basically like your address book. And then we also touched on the physical networks, routers, fiber connectivity, and all of that. But now we're going to see what is actually done with the packets that are sent across those networks. So it's good that we can send things to each other over the networks, but if we can't interpret them or understand them, then there's no use, right? So the more complex the message, the more sophisticated the tools also need to be to translate them. So we're going to be looking at the browser and the server side now. So internet can export to under the hood, the browser and the server. You know how they talk? Now let's see how they think. The high-level view is, first let's look at remembering how they work, right? So the browser sends a request and the server sends a response. As basic as that. Browser sends a request and the server sends a response. So those requests and responses are usually called the GET and PUSH protocols. If you are just looking for some information or data, then you do a GET protocol. If you need to send some information with that protocol, then you use PUSH. So that is like filling in a form and sending in your details across the network. Okay, but the basics of it is your browser sends a request and the server sends a response. Let's have a look at the browser. The browser isn't just a TV screen. It's a compiler and a renderer. So what that means, it takes the code that is sent to it and then it compiles it. So it translates it and then it renders into an image that is displayed on your screen. So it does this rendering from the code and into pixels 60 times per second. So it happens a lot. We don't even realize it, but it does it a lot. The critical rendering path, how do we get from code to visuals? Once it gets the code, how does it actually know what to do with it? There's different code in there. There's a lot of text. And how does it know what to do with this text and code? So first of all, it will look at the DOM. So it will create a document object model. The browser reads raw HTML bytes and turns them into a tree structure of nodes, parents, children, and siblings. So if you've ever seen HTML, I'll show you a file a bit later, but I think we all have seen some basic HTML. So you get your header, and then you get your bodies, tags, and then you get your paragraph tags or your link tags. So those are nested in each other. And those are your actual parents, your children, and your siblings, are those tags that it used to build the DOM with. The CSSOM is similar to the DOM, but for CSS. It calculates exactly which rules apply to which node, handling specificity like classes versus IDs. So it'll go and look at the class and ID parameter in your tags, and then find the styling on how it needs to render these pixels. So it'll not just give you the information, but it determines on how the information will look. Render tree. The browser combines the DOM and CSSOM to create the render tree. Things with display, none are not in this tree. So if things aren't supposed to be displayed, then they won't show up in this tree. So things that won't necessarily display is like JavaScript code or code that have other features in the page. So they handle other jobs like interactive pop-ups and things like that. So when you click it, the code will generate it and then do a pop-up, but you don't want to see that yet. So all of those things will not be in the tree display at that stage. Then the layout, the browser calculates the exact geometry, width, height, position of every box on the screen. And then the paint. The browser fills in the pixels, colors, shadows, borders and images are drawn onto layers. And then it layers that a file over each other, and then you will see it on your screen. Layout and paint costs. Why are some websites slow? Reflow layout. Calculate position and size, like measuring furniture for a room. Repaint. Filling the pixels like painting wall. Browsers try to avoid reflow because it's expensive and in computation. So the difference is basically, instead of trying to position everything relative to each other, which takes a lot of computation power, it's easier to just have a picture and then paint it. So you're actually just simulating the furniture and layout, but actually it's just an image of it. You're not trying to create the physical objects everywhere. You're just creating an image of it and painting it. So it's a lot quicker to do it that way than trying to calculate all the positions relative to each other. Then the server. The cloud is just a computer, but it's organized in layers, often called a stack. So we have the operating system, then the database, the app server, and the web server. So the operating system is where these database, app server, and web servers are housed. So what a request would look like is a request is web server. It's passed to the app server, which then queries the database. It retrieves the data, and the response is sent back. So when you send a request on the internet, say you want to load your dashboard on a cat website that will show you your pictures that you have liked before, it will send that request to the server. The web server, which is Nginx, Apache, or LiteSpeed, will get that request. It will then see what you need. So it'll say, okay, it needs the images for the user. So it's like, oh, wait, which user is this? It can't just know that. So that's when the app server comes in. The app server is the code that will now fetch the user data and go and speaks to the database to go and fetch that information. So it'll say, oh, I've gotten a request I got from the browser that you sent. I also got a push request that was the username. And so I now know the user. So the app server will say, please find the user on this database, and please find the images linked to this user. It will then compile that and get that data back, and then it will send you the response. So that's what the app server does. It speaks with the database, and then it also compiles that data back to be sent through the web server back to you. The receptionist versus the chef. The web server is the receptionist. It handles the connections, static files, images, CSS instantly. So that means if I was just looking at a cat image, it will point me directly to the file. But like I said, if I want all the images that I favorited, now it needs to have a database request. So it will pass a hard question to the app server. The moment it's more complicated, it will be handled by the app server, which is code like PHP or Node. The app server runs the logic. It talks to the database and builds the HTML page from scratch. Static versus dynamic. This is basically what we just discussed. It's a static is if it's just a pure file that needs to be sent to you. So it's already been generated. It's already sitting there ready on the server for you to receive on your side. It doesn't do anything to change it. That's a static file. A dynamically generated is built on demand. Once again, that's where we say it's if you, for example, send a user and it needs to send data back specific to your user, the app server will first go fetch the data and then generate the HTML from that. So that's a dynamic content. And then the last thing is memory. HTTP is stateless. The server forgets you immediately after replying. This is where cookies come in. To fix the memory loss, the server gives you a badge, a cookie. So why is this important? Sometimes if you've already logged in as a user, then the server will need to remember that you've already logged in. Otherwise, it would need to send that request over and over. It'll ask you, who are you? Who are you? That's not very efficient, right? It will drive you crazy. It'll send a cookie with the initial response back to you that has an ID that will link to the memory on the web server, basically. And then it'll handle requests like it does remember you. So it will, on your browser, there's a cookie ID, and it will say your session ID there. And once you've sent another request, that session ID will then be sent with your request, the new request you've sent. And the server will then know, oh, this person is logged in. I'm allowed to send them the information back, for example. That is why cookies are important. A quick summary is the browser. It parses the HTML. So parses is the compiling and the rendering into a DOM and then into a layout using the combination of the DOM and the CSS. And then it paints it onto your screen, basically. So it's literally sending pixel information to your computer screen, and that's when it paints it. The web server handles connections and static files. It can just give you a file that doesn't need to be changed or anything. It can give it to you directly, so it can skip the app server completely, which makes it faster. But sometimes we need more custom information. That's where the app server comes in. It runs logic and builds dynamic pages, and then builds your HTML from scratch and sends it back to you. And then the database stores the long-term data. That is where the app server goes and fetches the data that it needs to create and build the dynamic pages. Do you guys have any questions at this point?
Explain this to me before you continue.
Yes.
This is something I've never understood.
Yes.
When the query gets to a server,
Yeah.
you can have multiple websites on the same server. How
Yes.
does it know which website to load? Because there's no reference to the domain name there. The domain name is sitting on the DNS. The traffic's already here. Is it painting the packet? Is it like, how does that work?
Perfect. Your timing is perfect, because that's exactly what I wanted to show you now. This is actually where a lot of people kind of lose it at some stage. And if, as you're learning about this, you will get confused, but how does it know which files to go and look at? So it's actually a physical structure. Well, physical in a hard drive. It's not physical, it's digital, but it's a structure that it goes and looks at the address. So if you look here at the URL, right? So this is the protocol is over here. Then it's got the domain. So the domain will go to the DNS, and then it will go and find the IP on the DNS that I tell to go and look at.
We've associated the domain name with server's IP address.
Yes, 100%. Then the next part are the resources. And this is the part you're asking. So I'm going to show you now how it actually goes and fetches those files. And where does it know how to look? So I'm going to use FileZilla here. FileZilla, it's an FTP software that I can connect to servers with. So Bayers, you will see, I put in the host here for the server that I want to go to, right? So that would be the IP, correct? You understand? So that was what the DNS would have pointed to. Then with the username, when I log in here, you will see the structure of this web server. So this is actually the structure of the web server. When the web server's code, it knows where to go and look for the website specifically. It's programmed to go and look in a specific file when it gets a specific request. It'll tell you, if you give it a HTTP 80 request, it will know to go and look at the root of the folder structure, which it will have in home. So it knows I need to go into sites. So now you will see there is exponent.co.za. So that's the root of the exponent.co.za website. If you had another website, say for example, Google, google.com or google.co.za, and you had it on your server, there would be another folder here that said google.co.za. But now it saw in the request that no, I want exponent.co.za. So that's part of the request header in the packet. So it will go and look in here now and say, I need to go into this file. Now it knows to go and look into the HT docs file with the configuration. It goes into your configuration of your website, and it says the website is housed here, and there's all your website files. What you will see here now is, if you look at my URL, you will see there's presents here. Exponent.co.za presents. And why this is important, that is the path of the resource. If it's in the root, it will just actually go and look in here in the root file. But now here you will see there's a presents folder. It's going to say, wait, I need to go in there to go and fetch that HTML file. And there you will see there's my presentation. That's what it's viewing me right now. So this is the file it sent back to me. This was a static request. So it didn't go into PHP and any other code. It just went and fetched that static file directly because I put in the URL that directly pointed to that file.
And what you mean by static is it didn't need, well, it compiled the HTML, but it didn't need to generate or compile code from PHP to generate it.
Yes, I will show you a difference between a static and a dynamic request now. This is an actual file that we're looking at here. And if I open that file in a browser, doesn't matter if it's on my computer, it'll open it as well and show all the code. But now this file is just sitting on the server. So it just went and fetched it over there. For example, and this is where I want to show you where the tree structure comes in, the DOM, and then I can also show you the CSS. If I go over here now and I say inspect, this is what the HTML file will look like. So you will see the main file there. That is your parent, and then the divs. These are your children, your siblings, and then the parents at the top. And this is the physical tree structure that it's building with the code. And then it will also look on the right-hand side. If you guys check on this side, here is the CSS, the style sheet that it uses to lay over the data, basically to combine the DOM and the CSSOM so that it can create a tree structure. And now, where does it get all this information? Because this is from the browser's perspective, Nate. This is what it's actually showing us. But if I open my file in just a plain text editor or a code editor, this is the clean HTML file that's housed now. This is what it looks like on my end. You will see it's very similar to the one that the browser has, but yeah, this is the clean HTML file from our side. So this code and file literally sits on the web server. So when I asked to go and fetch this file, I sent the request to the web server. It looked at the address. So it found the address by looking at the domain. It went to the DNS, which is like your index for your phone book. It then said, oh, I need to go to this IP to go and fetch these files. It then went to the IP. Then on that IP, the web server got the request, and it's like, I need for exponent.co.za, I need to go look there. And then what do I need in the exponent folder? So it went, oh, I need to go into presents and then how the internet works with HTML. And then it sent that file back to me. Does that make sense to everybody? Does that give you like an actual picture that maybe like a light bulb goes off where it's like, this is how it all comes together? It's actually just fetching a file. This could have been an image, by the way, just a little picture on your computer. The same way that if you opened it on your computer, your image viewer would have rendered it. This is now just fetched on the server and it's rendered by your browser. Then a dynamic request. Let me open a new Gemini. So this was a dynamic request I just did. And I know it seems like, shut up, but what did you do? You didn't do anything. So I opened Gemini.google.com. But why this was a dynamic request is, how did it know to put my image at the top here? How does it know when to put Bayers' image there, Luzon's image there, my name? Um, it's got my conversations listed, my history. So how does it know that? That is a dynamic request. So I went to the Gemini.google.com site. Why did it not ask me to log in? Because I had a cookie. So it saw my session ID and it's like, oh, I know this guy. I need to link to his data on the database. So the web server saw that this is a dynamic request. And then it spoke to the app server. And the app server went, what do I need here? I need his image. I need the logo of the company. I need his name. I need his conversation history. And it used code to go and fetch all that data from the database. And then it built this page on the app server using code. And then only did it send back the HTML to my site that was already rendered there. Does that make sense for a dynamic versus a static request?
Yes.
100%. So just to recap, we've touched on the protocols. So the language that the physical infrastructure uses to communicate. So it's a TCP IP protocol predominantly. We've looked at how it knows where to find the information. So that's using the IP addresses, DNS servers, and DNS records. And then we've also looked at the protocol that they talk. It's the HTTPS protocols, so that it can understand and interpret each other. And now we've looked at what is actually communicating over these networks with each other, and that's your browsers and your service. So it's your client and your server. And now we've also seen how a file is fetched and actually how it is rendered and shown to you at the end of the day on your computer screen. I can show you one more example. It's pretty interesting. So if you right click on your browser page and you click inspect, it's very interesting, actually. I don't know if you guys done a deep dive in these little things. Probably not. Most of you not. I'm 100% sure Steve and Stuart probably and Jonathan has. But the interesting part at the top here as well is you can go and look at your sources. So these are files that goes and fetches. You can go and look at the network. So here you can actually look at a request happening over the network. So if I go and do a request here now and say, this example is to show the request is it. There it goes. It created the request. Now you can see all the packets flowing in between the servers. So these are the status is the response code. Response code 200 means good. I've got the file. I know what you're looking for. As 301, 302 is a redirect response. So it's like, say, Bayers, for example, I told you now that it goes and look at the server, man, to see the domain where the IP is. And now it gets there and it's like, my stuff isn't here. And then there's he finds a little man saying, oh, no, we moved it over here, So that's a forwarding address, basically. So that's what that request means. A 404 means if it can't find the page. So that's the status here. Then you get your type of the request. I'm not going to go into too much detail here. And then job. But this is actually the files being sent back and forth, the requests going back and forth over the network. And you can see the request times in milliseconds here on the right-hand side and seconds. So you can actually go and see what takes long to load, what's taking the longest, to get the information, to create some dynamic content. So for example, it does a batch execute. So it does multiple things in one request. So it does things multiple times. And that's also why it would take longer. So it took over 1 second to do this. They can be quicker, but it needs to run some code basically at the end of the day. 100%. That's me. I hope you guys understand the internet a little bit better now.
Yeah, thanks, Carlos. It makes a lot of sense.
Yes.
I've always had this theory about how the millennial, or especially the early millennials who grew up with a computer, like a PC in the house and all of that, I've always had this theory that we had to struggle to get the computers to work. Like we had to, like I remember trying to install games, like computer games, and then not having it work and trying to go to LANs. Like we literally had to build our own networks when we wanted to game against each other. We couldn't just log onto a server and play against any number of a million and millions of people on any game server that we wanted. We had to like literally pack up all of our stuff, go and meet each other on a weekend, on a Friday afternoon, basically set up our own networks. And understanding the difference between crossover cables, for example, and regular LAN cables, and figuring out the difference between a switch and a smart switch and a router. Like those seem like stupid little things, but if you think about it now, how advanced that actually was compared to the knowledge that the average person in IT has today. Like we had better understanding of networks and computer interfaces than most first line support IT people do today.
We do actually, because we wanted to play games. Yeah. So we needed to set up the IP addresses, the protocols. We needed to make sure that the computers can communicate with each other.
And if you were really lucky, you could then go and actually play games for a few hours, because usually the first half of the LAN weekend was usually dedicated towards just figuring out how to build it. But the amount of learning that you do, I mean, I remember the first time we did a LAN party, I tried to figure out how to get my computer connected. And I ended up basically gaming on my own because I couldn't figure it out. And then I had to go learn how to do it. And yeah, that's where learning from Theonis and learning from Cutoff, all of this stuff actually came in. And we got really good at computers and really good at understanding these things. And my theory, to continue the theory, is the millennial generation will be the last generation to really, like, of general population that understands how this stuff actually works and putting it together in practice, because everything now is so well built and so easily put together that it's like late stage computer science, or at the very least it's productized to the point where it's so easy you just log in and do what you want to do. And I don't know which one is better, because ultimately, if I think back to like the quotes, I can't remember which of the tech moguls it was, but they said this computer, or the home computer, is a solution looking for problems to solve. And they built it not really knowing what the world would do with the technology. And ultimately, I think it went through phases, and now people are actually using it to solve daily problems. And I think that if you think about AI, for example, people have been talking about the fourth industrial revolution being the internet, but I don't really think so. I think we're still in the third industrial revolution. We're just basically perfecting the technology, right? There was the microprocessor, which led to computers, which led to networks, which led to the internet. Now we've got artificial intelligence. That's all still the same technology. It's still just microprocessors and networks. So anyway, that's my take on it. And I think that the millennials have a huge advantage, which means absolutely nothing, because it results in us having to basically tech support.
Yeah. I think that a lot of people, I wouldn't say that less people actually understand these concepts. And the reason why is, I think even back then in school, how many people would you ask to set up a network and they'd be able to do it? 1%?
Yeah, I think it was a special group of people.
That's what I'm saying. And I think today's time, it's still the same. It's still the same people, the people who are interested in it, they know exactly how it works, and they'll set up a network. I mean, there's still people who need to set these things up, right? Physical network servers. It's just a bit different now. Now they do it more in a data center. So there's people, you'll find them most probably sitting on a data center. But I mean, even in the work networks and stuff, same people, they need to set it up. So I think it feels to us like, it was our generation, but I think it was just us. And I think that it's the same percentage maybe of people know how these things work, but that actually makes it more of them, right? As the world is expanding and as technology is expanding and more people are introduced to technology, and as the population is growing. So yeah, I just think it's not a lot of people are interested in this as much, and that's fine. You don't need to be interested in everything in the world, right? So they've got their own expertise, and we're the nerds at the end of the day. But yeah, I'm glad that hopefully you guys understand this a bit better. And why this is important is this is the fundamentals of our company. This is the basis of our company, because we are a digital marketing agency. Everything we do works on this protocol every single day. This presentation I'm doing now was done over that protocol. This company would not exist without these systems and protocols, literally. And that kind of excites me because this is to show that we've also been doing something interesting and new, and not a lot of people are doing in South Africa. I think it's growing now in a growing market, but think of it. We don't have an office. If we take away the internet, this company disappears. But if the internet is gone, we are gone. So I just think it's good to understand these basic principles of how these things work. And then you can also better explain to customers of what's possible, maybe what's not possible, and, what are the limitations at the end of the day. And we can build that understanding on what we've learned today. So I think in the future, Bayas, my next course will be on how to sell technology. So how we can actually bring this into something that's worth something now. Because great, you understand this now. And this is why people aren't interested into it a lot. Because what now? What are you going to do with all this information? But using this as a foundation, I will show you guys some things that you can actually practically use to sell clients, and then explain a bit to them of how, so that they can understand what they're buying. So what are they buying when they're buying a domain name? What are they buying when they're actually buying emails? What are they buying when they're buying a website? And understanding these fundamentals and how they work, you can easily explain it to them. And maybe if you seem more knowledgeable, you have a better chance of closing a sale at the end of the day.
Gerard, I think your next talk should be on something like, what's the difference between web hosting and proprietary hosting that we sell, for example, and how it makes a website operate better.
Yes.
And talking about why clients should opt for something a little bit more expensive and why it's beneficial to them. I think connecting the sort of underlying tech and our expertise with a real world benefit to the client is really what we need to understand next.
And this is why this was important, especially for the account executives, because, for example, if I tell you what's going to be different on our web hosting versus other web hosting, you'll be like, oh, it's faster because it uses a better web engine than those oaks. We use LiteSpeed, which is way quicker than Nginx, for example. And you don't even need to know all the names and stuff. Just understanding it, like how websites load faster, for example. We use a CDN, a content delivery network. So it's a dedicated space where we host the file separate from the other web server, so it can go and fetch it quickly because it's locally. So all those types of things you can understand better when people ask you, but why pay more? Then we can start using these tools to sell to them. And I'll go into that a bit deeper next time, Bayers, as the next one.
Well done, Gerard. That was very interesting. I enjoyed that.